Okay, so we've already done the case of uh, like line. So, for example, I was just discussing you with this particular problem. I was discussing this particular problem. That is, I took a line of charge. Sorry, let's do this way. Okay, so I was taking a line of charge. So I took a line of charge here, and that particular line of charge had a length L, and total charge Q was uniformly distributed over it. And if I wanted to find the force it exerts on this charge Q naught. So, for example, when I was doing this particular problem, the force exerted on this charge Q naught came to be, I think, K Q naught upon L into Y, and then I had L got divided, and this was like 1 upon root over Y square plus L square by 4, if I'm not wrong. This was the force that came up. Is that clear? So I told you that instead of instead of uh, instead of having some like no, because you have this particular line of charge, and if you have a line of charge you cannot invoke your Coulomb's law. Now what I have to do, I would take certain differential element dz, and in that your differential charge would be contained, and adding all those contributions up I will get the net force. Okay, so net force would then be equals to kq2 naught, and I've already told you that if my rod is way too large, way too distant from your charge q naught, that is if y is too much greater than y is too much greater than your, I can say, L. So what does it mean? That if I am at a very large distance, so this particular length L would appear very small to this particular charge Q naught. So at a very large distance, if y is very greater than L, then what will happen? I can take this y common out, and if I take this y common out, this will become 1 plus L square upon 4 y square. This will become 0. So overall, this will be like k q naught upon y square. So if I go at a very large distance, this particular rod will appear as if it has reduced to a point charge. Only in that case. Is that clear? Now, if I take L to be large, so if L tends to infinity, if my L tends to infinity, that is, if I have a case of infinite rod of length L, if my rod is instead infinite rod of length L, so if I have an infinite rod of length L, then what will happen? So if it is an infinite rod of length L, so it will be like, force will be like K Q naught divided by, you have a y here. Okay, you have a y here, and then you have something like L square by 4, you can take common out. So ultimately you can take L square by 4 common out, it will come out as L by 2 here. So it will come out as 2 K Q naught Q divided by y. Okay, and this will be L. And what is this Q naught by L? Q naught by L is nothing but it is equals to 2 K lambda. Sorry, what is Q by L? Sorry, Q by L is lambda, and what is Q naught? So this is like it is. Is that clear to you? I don't think there is a problem. So all these things are written in magnitude. In direction, if this is your y-axis, then all these forces are being exerted along the y direction. So if I have to write net force exerted on the y direction, it can be, there can be like, generally this will be the case, but in particular I can write it as k q naught, k q naught upon y square, provided my y is very large than L, and if my L is tending towards infinity, then this can be written as 2k lambda q naught upon y. Now, what would be the field that this particular rod of length would exert at this particular point? So instead of q naught, I can place a unit coulomb charge, or whatever force is being exerted on charge q naught. From there, I can extract my field. So what is my field? Limit q naught tends to 0. My force F vector divided by q naught. So what I would get? I would simply get this as k q, and this q naught would be like q naught divided by q naught will be 1. This will be, I think, y, and then there will be root over y square plus L square plus 4. And then there would be, I think, y cap. So this is electric field vector. Electric field vector also can be again reinforced and can be written as 2k lambda upon y, or simply lambda upon 2 pi epsilon naught y cap if L is very large. if L is very large. Is that clear? And if your y is very, very large, then L, then it will be k q upon simply y square. So it is like a electric field due to a point charge at a distance y. Is that clear? I don't think there is an issue till now.
Yes.
I
Yes.
don't think there is an issue till now. Okay, is that clear to you now? ये चीज समझ में आ रही है? Okay. Now all these cases were, I mean, I'll go very step by step because this is one topic where I can go at much speed, and as I told you, I have found many students struggling with my speed at least. मतलब उनको फिर ऐसा लगने लगता है कि they are getting everything, but when it comes to their own doing on their own, they cannot even do a single question. So that is why I'll take caution here, and I'll go very slowly. Okay. Now instead, this was a case where you had a uniform distribution of charge, isn't it? So you had a uniform distribution of charge. You had a uniform distribution of charge, means your charge q was uniformly distributed. Now I will rather place a problem in front of you, a little bit easier one. So I'll take a plane here. So I will take a non-uniform charge distribution case. Okay, so non-uniform charge distribution. So let's say if my rod, for simplification, I'll now place it not in z direction, I'll place it x direction so that सब कुछ तुम्हें सामने दिख जाए. So let's say this is your rod of length L. Now this is a rod of length L, and most possibly you have this kind of thing. So this particular now charge element, if I say now my charge is in such a manner that is distributed in such a manner that it is what I can say, it is like dependent upon the radial distance from the origin. So if I take instead of uniform distribution, if I take a non-uniform distribution such a manner that my charge distribution is now c into x, where x is the, you can take like this is a, and like let's say this is b. X is the distance from end a. Okay, so that it simplifies your thing. Okay, and this is the charge length L. Now what is happening now? At a you have zero charge at exactly at a, and as you go from a towards b, your charge is increasing because this is c times x. Now if I want to find my electric field at a point p, if I want to find an electric field at point p, and let's say it is at a distance r from b. So now how to write this expression? So what would be electric field at point p? Okay, now my question is suddenly altered, and now I have to find electric field at point P. How to find electric field at point P? Is that clear to you? Question समझ में आ गया? समझ नहीं है तो बता दो. So what is happening? Let's say this is my x-axis, this is my y-axis, and this is my z-axis. Now, if a rod is placed on the x-axis, along the x-axis, and if it is having if the rod is of length L, I have to find electric field at point P, which is at a distance r from B, and now the charge density is not uniform, rather it is non-uniform density. The uniform density cases we've already discussed. We've already discussed the cases where you have uniform densities. So forget about it. Now I have to do something for non-uniform case. So if I have a non-uniform charge density, so if my charge is distributed in non-uniform way, such that lambda is given by c times x, then I have to find what will be my electric field at point P. So I hope I have made things clear to you. How to find electric field at point P? Now, in order to find electric field at point P, what I would do is I would first take a small differential element. As I told you that if I want to execute any of my things from your Coulomb's law, I will have to take some small dq element, because the Coulomb's law is valid only for the point charges. So this dq would contains dq will be equals to some lambda times dx. And what is this dx? It would be distant from at a distance x. I'm taking a differential element dx. Is that clear to you? Now, what will be the force exerted by this dq charge at point P? So let's say I'll place a point charge Q naught here. I'll place a point charge Q naught here. What is the force exerted by this charge dq? This will be, I think, K dq into Q naught divided by what is the distance between these 2 points. So I have to write the distance between these 2 points. So total distance was L plus R. Okay, so L plus R was the total distance from A. From A it is L plus R, but now this element, so I have this distance X, what I would do, this is L plus R and minus of X. So this will give me this distance. Is that clear? So this will be L plus R minus X ka whole square. Any problem till now? And I'll not write a vector way. I'll just write I'll just write the force, and then I will take, if this is a point charge, positive point charge, then and this is a positive distribution. So total charge, total force will be in this x cap directions. So I'll write vector lately, but magnitude will be k dq q naught upon L plus R minus x whole square. Till now, anybody has any problem? Now, what would be field? Field would be, the field strength would be limit q naught tends to 0, your f upon q naught. And this will be, I think, k dq. Instead of dq, what you can do? Instead of dq, you can write lambda dx divided by L plus R minus x का whole square. Is that clear to you till now? कुछ बोल भी नहीं रहा. What is happening? अल्पना समझ में आ रहा है?
Yes, sir.
ठीक है done. चलो. So if this is the case, then electric field E is given by limit Q naught tends to 0. This is your F divided by Q naught. And then this will be, I think, K, and then this will be Cx dx divided by L plus R. थोड़ा सा कॉम्प्लिकेट हो गया प्रॉब्लम, पर कोई बात नहीं. L plus R minus x का whole square. Is that clear to you? And from where to where? All these differential elements will be collected from entire length. So this will go from 0 to complete length. Is that clear? So this will give me, so total electric field E will be equals to what? This will be equals to K C integration from 0 to x. This x I can write L plus R minus x. So I'll write a negative outside, and then I will write minus L minus R. I think it is clear. So I will write L plus R instead. And then I have L plus R minus x ka whole square. So I'm integrating with respect to x. R is a constant, L is a constant there. So now this will be minus Kc integration from 0 to L. This is 1 upon L plus R minus x dx. And then there is minus minus plus. This will be Kc L plus R integration from 0 to L, and this will be dx upon L plus R minus x ka whole square. I don't think there is an issue till now. And if I want to find total electric field at my point P, it will be equals to minus Kc. What will be the integral of this? This will be, I think, log of L plus R minus x divided by minus. So this will be plus. From where to where? From 0 to L. And then this will be, I think, minus Kc L plus R upon L plus R minus x, and then again minus, so this will be again plus. Okay, so from 0 to L. So overall, this electric field will come out as, I think, electric field E is equal to, if I just write this expression, so if I take this L here, so it will come as, instead of x only, I have to write, so it will be like K C. This will be L if I bring down, so this will be L plus R divided by L. So it divided by R, sorry. So if I just write L here, so L gets cancelled. So this is Kc L plus R divided by R minus Kc L plus R divided by, I think, L plus R. So this will be Kc here only, and this Kc would get cancelled with this Kc. So this will be Kc L upon R here minus, this will be, I think, no, sorry, plus, this will be Kc ln of L plus R, or probably R only, minus L, and then this will be minus Kc L plus R only. Okay, a log of L plus R. So overall, if I want to write my total electric field would be equals to, it will be equals to Kc upon R, and then you have plus Kc, and then you have R upon N plus R. Is that clear to you? So your net electric field at distance R from the rod and from the farther end of the rod. At the farther end of the rod, if I have this distance R given, then in all these terms, my electric field would be this way. Is that clear to you?
Yes, sir.
Okay. Now, instead, if I have a ring and my charge is uniformly distributed on the ring. So instead, if I have a ring and my charge is uniformly distributed over the ring, then how to find the net electric field at a distance? Now I'm doing electric field only because I hope I'm able to explain my Coulomb thing. So instead of force, I would be discussing field now. Okay, is that clear to you? So now, if I want to find electric field due to a charged ring at a distance z from the center of the ring, then how to find that particular thing? So there, that is my main focus. Okay, just give me a minute. Okay. So this will be like this. So I'll draw a ring. So I'll draw a ring for you here. ऐसे बना इसको बनाए कैसे? सोचना थोड़ा सा कुछ अच्छे से बना ले, लेकिन सब मत लगो. So if it is like this, कहाँ गए? So if it is like tap 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 tap. So we are considering a ring of negligibly small thin ring, ना थोड़ा सा इसमें thickness कम ही मान लो. So सब कुछ मिल जाए मुझे. ठीक है, तो thickness is negligibly small. Forget about it. Okay, and if I want to find what will be the field it exerts on at a distance z from the center of this ring. So how to find this particular thing? So what I would do is, let's say if I just take a charge element here. So if I just take a charge element here. So if I take a charge element here, okay, if I take a charge element here, and let's say this angle is d phi, this dq will be equals to what? This dq will be equals to, I think, lambda into d phi into r into d phi. Is that clear? Let's say this ring is of radius r, and let's say this distance is z, and this then this lambda can be written as net charge. Let's say it is q, then it will be given by q upon 2 pi r. Is that clear? Now, if I want to find what is the electric field this particular ring exerts on this particular point, so let's say I'll place a charge q naught, and I will just try to find the force it exerts on this charge q naught. Force it exerts on this charge q naught. And let's say this is your phi, then let's say this is your theta. Okay, is that clear to you? Okay, so I was thinking to make it in a very better sense, but only God knows kya kar sakte hain. So this is the force it exerts in this direction. So net force that would be added would be this. This is something that you know. Okay, so net force would be added here only along the z direction. Otherwise, by symmetry, all these forces would get cancelled. Is that clear? So only net force, I will say only net force will be along z direction. Is that clear? Okay, now if I want to find the field, so I have to first find the force, and force along z direction would be equals to what? Force along z direction will be integral of dfz, and that will be integration of df, and this is df, this is theta, so this will be df cos theta. Is that clear? And if I write df cos theta, so what it will be? I think it will be k, then instead of dq, I can write lambda into r into d phi, and instead of cos theta, I can write cos theta would be equals to what? Z upon, sorry, this I've forgotten, this will be root over z square plus r square. So what will be cos theta? Cos theta will be z upon root over z square plus r square. Okay, is that clear? Cos theta would be this, I have written here, and this is k dq, and this will be q naught upon r square. And what will be r square? This will be z square plus r square. Is that clear? So overall, this would be thing. I don't think, or ये सब चीजें I think you have had your course in standard 12, but only thing I want to do is कि थोड़ा सा तुम्हारा recap हो जाए, otherwise I would straight go, once I'll straight go to the topic, then there is no looking back. So that is why I want to spend some little bit of time on this. Otherwise वही वाली बात है कि चीजें कब बढ़ेंगी and then you will not be able to understand. इसलिए I want to take little bit of your time. Integral d phi. Is that clear? What would be integral d phi over this entire ring? This will be, I think, 2 pi. So this is 2 pi, this is k, then this is q naught, then this is lambda, then this is r. ना, if I'm not wrong, कुछ गलती तो नहीं कर रहे ना हम लोग, z divided by z square plus r square की power 3/2. Is that clear?
हाँ भैया।
है ना, पक्का कुछ गलती तो नहीं कर रहे हम करने में, पता चला कचरा हो गया फिर बाद में, और फिर बहुत ही ज्यादा पोपट हो जाएगी अपनी की, स्टैंडर्ड 12 की प्रॉब्लम नहीं हो पाई इनसे। ठीक है, सो नेट फोर्स इट exerts at on this particular thing z is a q naught is given by this. So net electric field along z direction would be limit q naught tends to 0 fz divided by q naught. So that would be, I think, q naught gets cancelled, and this lambda I can obviously write it as q upon 2 pi r. So I can write it as q upon 2 pi r. So 2 pi gets cancelled with another 2 pi. Only r remains, and r also get cancelled. So r and r get cancelled. So I'm left with k q z upon z square plus r square to power 3. Okay, is that clear? So vectorially, if I speak, vectorially to speak, my force will be in the my electric field will be in the z direction given by k q z upon z square plus r square की power 3/2 z. Is that clear? Okay, मैं कुछ गलती तो नहीं कर रहा हूँ, चेक कर लो एक बार, क्यों नॉट यही होता है फॉर्मूला जाकर के। ठीक है, डन। अरे बाबा हाँ है ना, तो बोलो फटाफट से, yes or
हाँ
no?
भैया।
Okay, now instead if I give you another thing, instead if I just take another case, and if I say that my uh, so now instead of this ring, I'm given with a ring, now I'll make in this fashion, otherwise हर बार उसको visualize करना तो आसान नहीं होगा. This thing you know ना, मतलब ये चीज पता है ना कि for example if I have this df appearing here, so there will be another diametrically opposite corner, you will have another. So overall only these components would add. Okay, this component, so for example if I have a on diametrically opposite corner, not even diametrically opposite corner, let's say here if I have another element, if I take another element, so I know that my net element total net like are you getting my point? So this will be like in this fashion. So you can understand that only these forces, only along z direction your components will be added, along x and y direction they won't be added. Okay, so by symmetry of the problem, you know that by symmetry you know that only z components will force along z components would only be there. Is that clear? So this is something that you know from standard 12th. I'm not going to spend much time there. Now instead, if you have a non-uniform distribution over the ring, so for example my ring contains now I'm giving you theta itself so that you don't get confused. So this is my ring. Now instead this is my ring, and now if I am I have this ring, and this particular ring has, let's say, non-uniform distribution of charge given by lambda is equal to lambda naught cos theta, where theta is like, let's say this is your x-axis, and let's say this is your y-axis, and this theta is an angle from x-axis. So this is your theta. Okay, now this is your theta, this is your dq. Okay, now, and this will be, I think, d theta. So overall understand that this particular ring now has a non-uniform charge distribution. Ring has a non-uniform charge distribution. such that lambda is equal to lambda naught cos theta, where theta is an angle from x-axis. So with respect to x-axis, theta is the angle. Okay, theta is the angle. Now if you are asked what will be the electric field, what will be the electric field? How would you find? What would be the electric field? How would you find? So from at a distance, let's say at a distance z from the center of the ring. So if from the center of the ring, if you go at a distance z, then what would be the electric field at a distance z from the center of the ring? So instead of lambda, now you have this lambda naught cos theta. Just let me know how would you do this problem.
And this based on cos theta, sir, the charge will be different, like in second and third quadrant.
Right. So now what will happen is, now instead of finding at a distance theta, at a distance, you should first thing, I think, you don't find at the distance z. At the very first case, it would be difficult for you. You just find, because it will again invoke a two coordinate system. I want to keep it simple. Just find this. कहाँ गया ये? Easy रखने के लिए एक काम करते हैं, पहले एक काम करो, just find. Otherwise it will be too difficult for you, because then you will have another angle, you have to keep that phi angle also along with that. I have not taught you now 3-dimension thing na. Ek kaam karo, just find electric field at the center for simplicity. Just find electric field at the center for simplicity. We'll do this problem also where it is at a distance like at z also, but then you will have another angle, you'll have to have another angle phi coming in place. So therefore, I'm skipping that problem. You just do it an easier version to this particular problem. Find the electric field at the center. So that would be an easier thing to do first. Now find the electric field at the center. So initially, you can see that if you had a non-uniform charge distribution, and if I say what will be the field at center, so you will say this will be, since this is 0, so your electric field will be 0. So if you have a uniform distribution of charge, so each of these charges will push the charge at the center in opposite direction. So let's say if you are taking dq here, and here is your q naught, that is the test charge is placed q naught here. So it will push in this direction, and exactly diametrically opposite end, if there is a charge dq, it will push in this direction. So if I place a charge q naught at this particular point at the center, in order to find the electric field, it will experience zero force, net zero force. So overall, I can say that my electric field at the center would be 0. Is that clear? But now, instead, if I have this non-uniform distribution of charges, and if I have to find the electric field at the center, so this is a problem I think from IRIDO only. But overall, just try to find the answer to this. So how would you go? So you know that you already know that if I just make this particular thing, so here यहाँ अपन देखते हैं. So let's say for a simple case, if I would have taken z ना, तो z axis के ऊपर जो क्या कह सकते हैं force it would have exerted, then I will have to have another phi, मतलब समझ पा रहे हो, another phi और एक और angle लेना पड़ेगा, and then things will become very complicated. So better अभी start कर रहे हैं, तो एक काम करते हैं, easier case लेते हैं. Let us place a charge at center. So let me place a charge q naught at the center. Now what will happen? All of these 4 quadrants, you see that in the first quadrant your cos is positive. Since cos is positive, so here you will have a positive density, which will be quite much in this end, and then it will be feeble and it will get feeble here. Why it will get feeble here? Because you know that your cos theta is a decreasing function from 0 to pi by 2. So if my theta goes from 0 to pi by 2, my cos theta is a decreasing function. And if my cos theta is a decreasing function, then at 0 it will be maximum, that is 1. And from 0 to pi by 2, if I go, there will be very less amount of charges here. Here you will have a negative charge density. Here also you will have a negative charge density. And mind you, this will not be the exact pictorial description, because I have drawn a very equidistant sort of distribution of charge. This will not be the case, although the case is more charge will be located at around origin than at pi by 2. So more charge will be located on the equatorial axis than the polar axis. Okay, is that clear to you? Since cos theta is decreasing, cos theta is a decreasing function, so possibly this is fine. There will be positive charges on the first and the second quadrant, first and the fourth quadrant, but second and third quadrant would have a negative charge, but this distribution of charge would be very non-uniform. So such distribution cannot occur on a metallic surface, because we know that in metallic surface the charges distribute themselves uniformly on the surface. Is that clear? So we have to find the electric field at the center. How would we find electric field at the center? Any ideas? So let me do it for you. So what I would take, I will take a differential element d theta at a angle theta. So this particular charge here would be equal to what? It will be, I think, lambda into r into d theta. Is that clear? This is r, this is d theta. So arc length is d theta. So lambda dl, instead of lambda dl, I have written lambda into r into d theta. Is that clear to you?
Yes.
Okay. Now, um, like absolutely fine. And what would be if I just take here another angle, but this will be minus theta and this will be d theta. So what will be here? Here you can again take lambda r d theta, and you just see that this will be in this direction. Sorry, this particular charge will exert force in, this particular charge will exert force in this direction, and this particular charge will exert force in this direction. Okay, this particular so net charges will be added in this direction. Also understand that this is a negative distribution here. So if I make a dq here also, so what will happen? This will attract in this direction, and here if I make a dq element, this will attract in this direction. Is that clear? So my net electric field now would be 2 times differential dE, and this will be, I think, dE, this is theta, so this is 2 dE cos theta. Is that clear? And my theta is varying from minus pi by 2 to plus pi by 2. Is that clear? See what is happening. If I take just this particular thing, so if I'm just taking this particular side, so if I just see this particular side, what is happening? If I just take dq element here, if I just take a dq element here, what is happening? This particular dq element will push q naught in this direction, and this particular dq element will push in this direction. So by symmetry, I know for all these side which I'm indicating, my net electric field will be dE cos theta, because total would be added in this direction. This will be dE cos theta. This is theta, so this will be dE cos theta. But also understand that this hemisphere is negatively charged, so obviously this element Q naught would be attracted equally by an equal amount of force. So what will happen? Overall, the net electric field will become 2 times dE cos theta. Integration is being taken from minus pi by 2 to plus pi by 2. Is that clear to you?
Yes, sir.
Is that clear to you, or should I do it all over again?
Yes, sir. Clear.
Clear है ना? आवाज नहीं आ रही. चलो, जो भी है. So this is like 2 times integral minus pi by 2 to plus pi by 2, and this will be dE will be what? dE will be equals to k dq, and dq is, I think, lambda r d theta. So this will be lambda naught cos theta, and then this will be r, and then this will be k dq upon distance r square. So no longer I'm taking q naught here. If I take a q naught here, I will have to divide this particular force expression by q naught again and take limiting value. So overall it will give me k dq upon r square. So k dq upon r square from minus pi by 2 to plus pi by 2. So net electric field. So your net electric field would be equals to 2 times integration from minus pi by 2 to plus pi by 2. This will be k lambda naught upon r. And what is integration of cos theta? Cos theta integrates, give me sin theta, and sin theta from minus pi by 2 to plus pi by 2 will give me again a 2. This will be again a 2.
Then there will be a cos theta term, no?
Acha, okay. This will be cos square theta, I think, right? Because this theta is there, so this will be cos square theta. And how to integrate cos square theta? You can write 1 minus 1 plus cos 2 theta divided by 2. So you can write 1 plus cos 2 theta divided by 2. So I can write 1 plus cos 2 theta will be theta plus, I think, sin 2 theta divided by 2. Is that the case? And if I take this particular case, then what will happen? I think that net electric field would then be equals to what? Net electric field will be in the minus I cap direction. First thing is minus I cap also I should write. So it will be in minus I cap direction. So it will be like K lambda naught upon R. And then this is like pi and sine 2 into pi by 2 sine pi, forget about it. So overall the answer would be lambda naught upon 4 epsilon naught R minus I cap. So net electric field would be acting along the x-axis, x direction, and this will be lambda naught upon 4 epsilon naught R minus I cap. Is that clear to you?
Pi.
Yeah, okay. So all of these problems, I mean, there are too many problems in this particular section that we're going to do. So you will have to keep some patience because we were doing some very advanced stuff and I just plunged you into a very basic sort of thing. Why I plunged you? Because I know if I take a very advanced approach to all those things, but then you will not be able to understand or much follow it. So I've done a few basic questions. I'll do a few more basic questions tomorrow also. But my only request to you is just go and revise whatever you've done in at least standard 12th, not beyond that. At least standard 12th, you have this NCERT book, textbook. You just go through that NCERT textbook. That is a very beautiful. I had never gone through that NCERT textbook while I was in standard 12th. Okay, so I used to study from Halliday and Resnick. But when I was teaching a NEET person, I happened to read that particular book. I can say that particular book is quite advanced. And secondly, it is like it puts everything in a very very limited amount of pages. So for people like you who just want to get a basic revision, you just go through that particular textbook. So that would be good enough. And if you have certain preferences, then go ahead with that. I have no issues. But overall, understand, I would need your cooperation here because kitna basic pe jana hai, kitna nahi jana hai, depends upon your growth. So that is one thing that is required. Is that clear to you? So tomorrow we'll start with Gauss law and we'll see that how certain things that we are deriving using very rigorous integral, we'll be able to do it by a Gaussian approach also. And possibly one lecture we would take of Green's function. So this will remain only of one lecture. Another lecture we'll take of Green function. For Green function, I would only require your at least know-how of second order differential equation, not beyond that. So Green's function we'll start tomorrow. Okay, so Green's function surely tomorrow and one lecture of this electrostatic part. Is that clear?
Yes, sir.
Okay, so I don't have much time, so that is why I was. Any doubt, any problem, let me know.
भैया मेरे को ये वाला समझ में नहीं आया कोऑर्डिनेट वाली कॉन्सेप्ट।
अच्छा ओके देखो यहाँ पे चार्ज dq रखा है, dq will be lambda r d theta, lambda is lambda not cos theta. Okay, so lambda is lambda not cos theta. यहाँ पे तुम चार्ज जैसे मान लेते dq रखा है और यहाँ पे q नॉट रखा है, तो it will push in this direction. और जस्ट इधर की तरफ देखो, this will push this particular charge at center in this direction. So net charges, net force, net electric field, you can say, because of this particular sort of hemisphere would be dE cos theta, because these components would get cancelled. Only this component would remain. Is that clear? But also
ये तो आगे भैया मतलब
हाँ, but
ये this I understood, but वो जैसे आपने स्टार्ट किया ना क्वेश्चन को, तो फिर वहां पे मतलब कोऑर्डिनेट वाला सीन ले लिया, वो मेरे को नहीं समझ में आया कि कोऑर्डिनेट में क्यों लिया, मतलब ऐसा, या तो आई मिस द क्वेश्चन।
देखो थीटा like आपका जो चार्ज डेंसिटी it is given by lambda is equal to lambda not cos theta. Is that clear? थीटा यहाँ पर क्या है? थीटा is the angle from x axis. तो होगा क्या? फर्स्ट क्वाड्रेंट में थीटा कहां से कहां जाता है? 0 से पाई बाय 2. इट विल बी पॉजिटिव. सेकंड क्वाड्रेंट में थीटा पाई बाय 2 से पाई जाता है, यहाँ cos थीटा क्या होता है? नेगेटिव. तो यहाँ नेगेटिव डेंसिटीज होंगी. पर इन प्रिसाइसली यहाँ बहुत ज्यादा होंगी क्योंकि cos पाई होता है -1 और यहाँ बिल्कुल कम होंगी. अगेन यहाँ पर भी ऐसी नेगेटिव और फोर्थ क्वाड्रेंट में cos पॉजिटिव होता है. सो दिस विल बी पॉजिटिव. सो ओवरऑल ये नेगेटिव वाली भी तो इसको अट्रैक्ट करेंगे, मतलब this charge Q0 will be attracted in equal amounts. Overall this will amount to 2 dE and this will be cos square theta, and this will be cos theta, and this dE contains lambda naught cos theta, so this will be lambda naught cos square theta. Is that clear?
Right.
And so overall integrated, I think cos square theta is 1 plus cos 2 theta, and all those things will fall in place. I think this is again a problem here. Achha, sin 2 theta divided by theta. Okay, done. I think answer is right. This is what answer comes. I know this is lambda not equal to 4 epsilon naught. So we'll discuss quite many things tomorrow. Okay.
Yes, sir. Thank you, sir.